Close your eyes and listen. The rain is falling, and as each drop touches the earth, something remarkable is happening inside your mind. This is the story of rain, your brain, and the ancient connection between them. Long before we had walls and roofs, long before we understood what sound even was, our ancestors lived beneath the open sky. When rain began to fall, it meant something important. It meant survival. Water for drinking, water for crops, water for life itself. And so, over millions of years, the human brain developed a relationship with the sound of rainfall that runs deeper than conscious thought. Let us begin this journey in the most primitive part of your brain, the part that has existed for hundreds of millions of years. This is your brainstem, the ancient core that you share with reptiles and the earliest mammals. When rain sounds enter your ears, they travel as vibrations through the air, causing your eardrums to flutter gently, approximately 20 to 20,000 times per second depending on the pitch. These mechanical movements are converted into electrical signals that rush along your auditory nerve, racing toward your brain at speeds of up to 120 meters per second. The first stop on this journey is your brainstem, specifically a structure called the cochlear nucleus. Here, your brain begins its first analysis of the rain. It notices something crucial. Rain sounds contain what scientists call pink noise. Unlike white noise, which contains equal energy at all frequencies, pink noise has more energy in the lower frequencies and decreases as frequencies get higher. This creates a sound that is fuller, deeper, and more natural than pure white noise. Your brain recognizes this pattern instantly, even though you are not consciously aware of it. Pink noise has a frequency spectrum that decreases by 3 decibels per octave, creating what mathematicians call a 1/f relationship. This same mathematical relationship appears throughout nature, in the rhythm of your heartbeat, in the patterns of coastlines, in the structure of DNA, and in the fluctuations of the stock market. When your brain encounters pink noise from rainfall, it is encountering a mathematical pattern that mirrors the fundamental rhythms of life itself. As the rain signals travel deeper into your brain, they reach the thalamus, your brain's central relay station. The thalamus is making a crucial decision right now. Is this sound a threat? Your survival depends on this structure's ability to quickly identify dangerous sounds like a predator's approach, a falling tree, or a cry for help. The thalamus analyzes the rain sounds and finds them steady, predictable, and non-threatening. There are no sudden spikes, no irregular patterns that might indicate danger. The rain is constant, reliable, safe. This decision by your thalamus triggers a cascade of calm throughout your nervous system. When sounds are deemed safe, your thalamus reduces the stress signals it sends to your amygdala, the brain's fear and anxiety center. Your amygdala, which spends much of modern life on high alert due to traffic noises, notification sounds, and unpredictable environmental chaos, begins to quiet down. The rain is telling your ancient brain that you are in a safe place, that no predator would hunt in this weather, that you can lower your guard. Now the rain sounds reach your auditory cortex, located in your temporal lobes on both sides of your brain. Here, your brain begins the sophisticated work of actually processing what rain sounds like. Your auditory cortex contains approximately 100 million neurons dedicated to understanding sound. These neurons are organized in a remarkable way. They form what's called a tonotopic map, where different neurons respond to different frequencies, arranged from low to high like keys on a piano keyboard. Rain sounds activate a broad swath of this neural piano. A single rainstorm produces frequencies ranging from about 250 Hz for the deepest rumbles to 16,000 Hz for the highest pings of drops hitting metal or glass. This broad activation creates what neuroscientists call auditory masking. The rain sounds are filling up your auditory cortex's processing capacity, leaving less room for your brain to focus on other sounds that might disturb you: the hum of a refrigerator, distant traffic, a neighbor's footsteps, or your own worried thoughts. This masking effect is particularly powerful because rain sounds are what acousticians call non-rhythmic stochastic processes. In simpler terms, rain is random. Each drop falls independently, creating an unpredictable pattern that nevertheless maintains a consistent overall volume and tone. Your brain cannot predict exactly when the next drop will fall, so it cannot habituate to the sound. Unlike a ticking clock, which your brain learns to ignore after a few minutes, rain maintains your attention at a subconscious level without being intrusive or alarming. As you continue listening, structures deep within your brain begin to change their activity. Your locus coeruleus, a small cluster of neurons in your brainstem, starts to reduce its firing rate. This tiny structure, containing only about 15,000 neurons, is your brain's primary source of noradrenaline, the neurotransmitter that keeps you alert and vigilant. When the locus coeruleus detects the safe, predictable pattern of rain, it interprets this as a signal that high alertness is not needed. Your noradrenaline levels begin to drop, and with them, your sense of urgency and worry. At the same time, your brain's default mode network begins to activate more strongly. This network, which includes parts of your prefrontal cortex, posterior cingulate cortex, and medial temporal lobes, becomes active when you are not focused on the external world. It is the network of daydreaming, of internal reflection, of memory consolidation. The rain sounds, by occupying just enough of your attention to mask intrusive thoughts but not enough to demand active processing, create the perfect conditions for this network to flourish. Your brain waves are shifting now. If we could measure the electrical activity across your cortex, we would see your beta waves, the fast waves of active waking consciousness that cycle 13 to 30 times per second, beginning to slow down. They are being replaced by alpha waves, cycling 8 to 13 times per second, the waves of relaxed wakefulness. If you continue listening, theta waves will begin to emerge, cycling 4 to 8 times per second, the waves that appear as you drift towards sleep. There is a particular structure in your brain that finds rain sounds especially soothing: your hippocampus. This seahorse-shaped structure, located deep in your temporal lobes, is responsible for forming new memories and for spatial navigation. But it also plays a crucial role in emotional regulation and stress response. Your hippocampus contains receptors for cortisol, your body's main stress hormone. When cortisol levels are chronically high, it can actually damage hippocampal neurons. Rain sounds help reduce cortisol production by signaling safety to your amygdala and hypothalamus, protecting this vital structure. The hippocampus has another remarkable property. It contains some of the few areas in your adult brain where new neurons continue to be born throughout your life, a process called neurogenesis. Stress inhibits this neurogenesis, while relaxation and good sleep promote it. The rain sounds you are hearing are creating conditions that may, night after night, help your brain grow new neurons in this crucial region. As the rain continues to fall, your autonomic nervous system is undergoing a profound shift. This system, which controls all the body functions you do not consciously think about, has two main branches: the sympathetic nervous system, your fight or flight response, and the parasympathetic nervous system, your rest and digest response. Modern life keeps many people in a state of sympathetic dominance, heart rate slightly elevated, breathing shallow, muscles tense, always ready for action. Rain sounds help tip the balance toward parasympathetic dominance. Your vagus nerve, the main nerve of the parasympathetic system, increases its activity. This nerve, which runs from your brainstem down through your chest and into your abdomen, sends signals that slow your heart rate, deepen your breathing, relax your muscles, and improve your digestion. The sound of rain is essentially giving your vagus nerve permission to take over, to switch your body from doing mode to being mode. Your breathing is slowing down now, becoming deeper and more regular. This happens partly because your brain is mimicking the rhythm of the rain. Although rain falls randomly, it creates a steady auditory texture that your brain interprets as a kind of rhythm. Your brainstem contains what neuroscientists call central pattern generators, neural circuits that can produce rhythmic outputs. These circuits coordinate your breathing, your heartbeat, and your walking gait. They have a tendency to synchronize with environmental rhythms, a phenomenon called entrainment. While the rain itself has no single rhythm, the consistent texture of rainfall creates what might be called a meta-rhythm, a sustained pattern of sound that your breathing can match. This is why people naturally breathe more slowly when listening to rain. Their central pattern generators are entraining to the calm, steady presence of the downpour. In your brain's prefrontal cortex, the area right behind your forehead, something important is happening. This region, which is responsible for planning, decision-making, and worry, is finally quieting down. The prefrontal cortex is remarkably energy-hungry, consuming about 20% of your brain's glucose despite being only about 10% of its volume. Much of this energy goes toward what psychologists call the inner narrator, the voice in your head that comments on everything, plans for the future, and rehashes the past. Rain sounds help silence this inner narrator. Because the prefrontal cortex evolved relatively recently in evolutionary terms, it is less directly connected to your auditory processing than older structures. The rain signals that tell your ancient brain you are safe take time to reach your prefrontal cortex, but when they do arrive, they carry a powerful message. There is nothing to figure out right now, nothing to plan, nothing to worry about. The rain will fall whether you think about it or not. Deep within your brain, your pineal gland is beginning to release melatonin, the hormone of darkness and sleep. The pineal gland is remarkable. It is one of the few unpaired structures in your brain, sitting right on the midline, and it is the only brain structure that lies outside the blood-brain barrier. Ancient philosophers called it the seat of the soul. Modern neuroscience understands it as your body's timekeeper. Although melatonin production is primarily controlled by light levels detected by your eyes, it is also influenced by your overall state of arousal. When rain sounds reduce your stress levels and increase parasympathetic activity, they create conditions that support melatonin release. Your pineal gland is responding to the message from the rest of your brain. It is time to rest. Your cerebellum, at the back of your brain, is also responding to the rain. This structure, which contains more neurons than all the rest of your brain combined, is primarily known for controlling movement and balance. But it also plays a crucial role in predicting sensory events. Your cerebellum is constantly trying to predict what will happen next based on patterns it has learned. With music, your cerebellum learns to predict the next beat. With speech, it predicts the next word. With rain, your cerebellum cannot make precise predictions because each drop is random, but it can predict the overall texture and volume. This puts your cerebellum in an interesting state. It is active enough to be engaged but not so challenged that it becomes frustrating. This gentle engagement without challenge is part of why rain sounds are so soothing. Your cerebellum is working, but peacefully, like a person doing a familiar, easy task with their hands. The rain sounds are also affecting your brain's production of neurotransmitters. We have already discussed noradrenaline decreasing, but other chemicals are changing too. Your brain is increasing its production of serotonin, often called the contentment neurotransmitter. Serotonin is produced in your raphe nuclei, clusters of neurons along your brainstem. When stress decreases and parasympathetic activity increases, these neurons become more active, releasing more serotonin into your brain. Serotonin does many things. It improves your mood, it regulates your appetite, it helps consolidate memories, and crucially, it is the precursor to melatonin. That serotonin your brain is producing right now will be converted into melatonin by your pineal gland, further deepening your relaxation and preparing you for sleep. Your brain is also adjusting its production of GABA, gamma-aminobutyric acid, the main inhibitory neurotransmitter in your nervous system. While some neurotransmitters excite neurons and make them more likely to fire, GABA does the opposite. It calms neurons down, making them less likely to fire. About 20 to 30% of all neurons in your brain use GABA as their primary neurotransmitter. When you are stressed or anxious, GABA activity is often too low, allowing neurons to fire too easily, creating racing thoughts and difficulty relaxing. Rain sounds help increase GABA activity through several mechanisms. By reducing stress and activating the parasympathetic nervous system, they create conditions where GABA neurons can function more effectively. This increased GABA activity is part of why rain sounds help quiet your mind. Your neurons are literally becoming less excitable, less likely to fire off in the patterns that create worry and rumination. As the rain continues, your sense of hearing is demonstrating one of its most remarkable properties, its incredible dynamic range. Your ears can detect sounds ranging from the threshold of hearing at 0 decibels to sounds as loud as 120 decibels before pain occurs. This is a factor of 1 trillion in terms of sound pressure. Rain sounds typically fall in the range of 40 to 60 decibels, right in the sweet spot of sounds that are loud enough to mask other noises but quiet enough to be non-threatening. Your ears are also showing their frequency sensitivity. Humans can hear frequencies from about 20 Hz to 20,000 Hz when young, though this range narrows with age. Rain produces sound across this entire spectrum, but most of its energy is concentrated in the frequencies between 250 Hz and 4,000 Hz. This happens to be exactly the frequency range where human speech occurs, which is why rain is so effective at masking the sound of distant conversations or other human-made noises that might disturb your rest. The physical structure of your ears is designed in a way that makes them particularly responsive to rain sounds. Your outer ear, the pinna, is shaped to collect sound waves and funnel them into your ear canal. Its complex folds and ridges create subtle acoustic filtering that helps you determine where sounds are coming from. Rain sounds, arriving from many directions at once, create a diffuse acoustic field that your brain interprets as surrounding you, enveloping you, protecting you. Inside your ear, the sound waves are moving your eardrum, a thin membrane about 8 to 10 millimeters in diameter. Behind your eardrum lie the three smallest bones in your body, the malleus, incus, and stapes, collectively called the ossicles. These bones form a mechanical lever system that amplifies the pressure of sound waves by a factor of about 1.3 and increases the force by a factor of about 30 through a reduction in the area from the eardrum to the oval window of the cochlea. The rain sounds, now amplified, enter your cochlea, a spiral structure that looks like a snail shell. Inside the cochlea, the sound waves create traveling waves along the basilar membrane, a flexible structure that varies in stiffness along its length. High-frequency sounds create waves near the entrance of the cochlea, while low-frequency sounds create waves near its apex. This is how your ear separates sound into different frequencies, performing a biological Fourier analysis in real time. Along the basilar membrane sit the hair cells, the actual sensory receptors of hearing. You have about 15,000 of these cells in each ear, arranged in 4 rows. Each hair cell has 50 to 100 tiny projections called stereocilia on its top surface. When the basilar membrane moves, these stereocilia bend, opening ion channels that allow charged particles to flow into the cell. This creates an electrical signal that is transmitted to the auditory nerve. These hair cells are so sensitive that they can detect movements smaller than the width of an atom. They can respond to vibrations that displace them by less than 1 nanometer. This extraordinary sensitivity means that your ears are constantly receiving information about the most minute variations in the rain sounds, the difference between a drop hitting a leaf and a drop hitting the ground, the subtle change in intensity as wind shifts the rain's direction, the faint echo of rain from distant surfaces. Your brain is using all this information to construct what psychologists call an auditory scene. This is your brain's best guess about what is happening in the world around you based on sound alone. Right now, your brain is constructing a scene of rain, but it is also inferring other things. You are probably indoors or sheltered because the rain sounds have a certain quality. You are probably safe because rain sounds are associated with being secure while weather happens outside. You are probably not required to take any action because rain is a natural process that will continue whether you do anything or not. This auditory scene construction is happening in your auditory cortex, but it is informed by many other brain regions. Your visual cortex may be contributing memories of what rain looks like, even though your eyes are closed. Your parietal lobes are constructing a sense of space around you. Your limbic system is adding emotional coloring, the feeling of comfort, safety, and peace that rain sounds evoke. As you sink deeper into relaxation, your thalamus is beginning to exhibit a phenomenon called thalamic gating. The thalamus acts as a gatekeeper, deciding which sensory information gets passed onto your cortex. As you approach sleep, your thalamus becomes more selective, blocking more and more external sensory information from reaching your conscious awareness. However, it continues to monitor for important sounds, your name being called, an alarm, a baby crying. The rain sounds, being both constant and non-threatening, are allowed through in a muted, background way that supports rather than disrupts your descent into sleep. Your brain's glymphatic system is preparing to become more active. This system, discovered only in 2012, is your brain's waste clearance system. During waking hours, the space between your brain cells is relatively small, about 14% of total brain volume. During deep sleep, this space expands to about 23%, allowing cerebrospinal fluid to flow more freely through your brain, washing away metabolic waste products that have accumulated during the day. One of the most important waste products the glymphatic system removes is beta amyloid, a protein that accumulates in the brains of people with Alzheimer's disease. By helping you achieve deeper, more restorative sleep, rain sounds are indirectly supporting this critical cleaning process. Your brain is preparing to take out the trash, and the rain is helping by keeping you in the deep sleep stages where this cleaning is most effective. Your brain's temperature is also beginning to drop slightly. Your body's core temperature follows a circadian rhythm, dropping at night to support sleep. Your brain's temperature follows a similar pattern. As you relax to the sound of rain, blood vessels in your extremities dilate, allowing heat to escape from your hands and feet, which helps lower your core and brain temperature. This slight cooling is part of the sleep initiation process. The neural networks that support consciousness itself are beginning to change their patterns of connectivity. Consciousness appears to require communication between different regions of your brain, particularly between your prefrontal cortex and posterior regions. As you approach sleep, this long-range communication begins to break down. Different regions of your brain start to act more independently, less coordinated with each other. This breakdown and integration is part of what causes your thoughts to become fragmented, dreamlike, and eventually to disappear altogether as you fall asleep. The rain sounds are facilitating this process by reducing the need for your brain to maintain active vigilance. When your environment is quiet and safe, your brain can afford to reduce the integrated alertness that consciousness requires. You can let go of the unified self that navigates the waking world and allow your brain to fragment into the separate processing regions that characterize sleep. Your immune system is also responding to your relaxation. Stress suppresses immune function, while relaxation and sleep support it. As your cortisol levels drop and your parasympathetic nervous system becomes dominant, your immune system becomes more active. Your body is increasing its production of natural killer cells, T cells, and antibodies. The rain sounds you are hearing are not just relaxing your mind, they are strengthening your body's defenses against disease. In your gut, often called your second brain because it contains about 100 million neurons, changes are also occurring. Your enteric nervous system is heavily influenced by your vagus nerve, and as that nerve becomes more active in response to the rain sounds, your digestive system relaxes and becomes more effective. Your gut is increasing its production of serotonin. In fact, about 90% of your body's serotonin is produced in your gut. This serotonin affects your mood and helps regulate your sleep-wake cycles. Your muscles are releasing tension in waves. As your brain sends signals of safety and relaxation, your motor cortex reduces its activity. Your muscles have been maintaining a baseline level of tension all day, ready to move at a moment's notice. Now that tension is melting away. Your jaw unclenches. Your shoulders drop. Your hands unfold. The rain is giving your body permission to let go of the readiness that kept you alert and active during the day. The sound of rain is also triggering memories, though you may not be consciously aware of them. Your hippocampus and adjacent memory structures are activating patterns associated with past experiences of rain, childhood afternoons indoors while storms raged outside, camping trips where rain drummed on tent fabric, quiet mornings watching rain streak down windows. These memories, though not in your conscious awareness, color your emotional response to the rain with layers of comfort and safety accumulated over a lifetime. There is something profound happening in the relationship between the rain sounds and your sense of self. Philosophers and neuroscientists have long puzzled over how the brain creates the feeling of being a unified self, a single you that persists through time. This sense of self requires considerable neural energy to maintain. Your brain must integrate information from all your senses, from all your memories, from all your goals and desires, and create from them a coherent narrative of who you are. The rain sounds are allowing this integration to gently dissolve. As you relax more deeply, the boundaries between you and your environment begin to soften. The rain is outside, but its sound is inside your ears. It is a physical vibration in the world, but also an electrical pattern in your brain. Where does the rain end and your experience of it begin? As sleep approaches, your brain stops trying so hard to answer this question. The self becomes more fluid, more permeable, less defended. This dissolution of boundaries is part of what makes rain sounds so deeply restoring. Modern life requires us to maintain strong boundaries between self and other, between work and rest, between different social roles we play. This boundary maintenance is exhausting. The rain sounds offer a respite, a space where you can let those boundaries soften, where you can simply be an organism responding to weather, no more separate from nature than a tree or a stone. Your sense of time is changing too. Time perception requires active neural processing, particularly in your prefrontal cortex and cerebellum. These regions are becoming less active as you relax, and with them, your sense of time becomes less precise. Minutes may feel like hours or hours like minutes. Eventually, time may seem to disappear altogether. The rain has no beginning and no end, it simply is. And as you listen, you begin to exist in that same eternal present, that timeless now where past and future fade into irrelevance. As you approach the threshold of sleep, your brain is exhibiting what sleep researchers call sleep spindles MK complexes. These are distinctive patterns of electrical activity that appear in your electroencephalogram as you transition from wakefulness to sleep. Sleep spindles are brief bursts of oscillatory brain activity, cycling at 11 to 16 times per second, that appear to play a role in memory consolidation and sensory gating. K-complexes are single high-amplitude waves that help suppress cortical arousal and keep you asleep. The rain sounds are supporting the emergence of these sleep-related brain rhythms. By keeping your arousal level low and your environment predictably calm, they allow your brain to initiate the complex sequence of neural events that constitute falling asleep. This is not a sudden transition but a gradual process, a gentle gliding from one state of consciousness to another. Your brain's production of adenosine has been building all day. Adenosine is a byproduct of neural activity. The more your brain works, the more adenosine accumulates. Adenosine binds to receptors throughout your brain and creates what we experience as sleep pressure, the increasing need for sleep as the day goes on. Caffeine works by blocking adenosine receptors, which is why it keeps you awake. Now, as you listen to the rain, adenosine is binding to its receptors freely, unopposed, adding its voice to the chorus of neurochemicals and neural patterns that are pulling you towards sleep. The rain continues to fall, and your brain continues to respond, in ways both conscious and unconscious, in systems ancient and modern, in processes simple and complex. You are a biological organism evolved over millions of years, and rain has been part of your environment for all that time. Your brain knows rain. It knows what rain means. It means water. It means life. It means you can rest while the world renews itself. And so you let go. Your breathing deepens and slows. Your heart rate settles into its restful rhythm. Your muscles release completely. Your thoughts, which have been growing more fragmented and dreamlike, finally dissolve into the darkness of sleep. The rain falls on, but you are no longer listening, not consciously. You have crossed the threshold into sleep, where your brain will spend the next hours engaged in its vital work of restoration, repair, memory consolidation, and preparation for the next day. But even in sleep, at the deepest levels of your brain, the rain sounds continue to have their effect. They maintain the environment of safety that allows you to stay in deep sleep longer. They mask disruptive noises that might otherwise wake you. They support the slow, regular rhythms of the sleeping brain. The rain is keeping watch so you don't have to. Hours will pass this way. The rain may continue or it may stop, but the effect it has had on your brain will persist. You will cycle through the stages of sleep, light sleep, deep sleep, REM sleep, and back again, several times through the night. In each stage, your brain is doing different but essential work. In light sleep, you are consolidating memories and processing emotions. In deep sleep, you are physically restoring your body and clearing metabolic waste from your brain. In REM sleep, you are dreaming, making creative connections between disparate memories, and regulating your mood. The rain sounds have helped you access all these stages. By reducing the stress and arousal that can keep you in light sleep, they have allowed you to descend into the deep sleep where the most restorative processes occur. By maintaining a calm acoustic environment, they have prevented the awakenings that can fragment sleep and reduce its quality. When you eventually wake, you may not remember the rain. You may not consciously realize how it affected your brain and body through the night. But you will feel its effects. You will feel more rested, more restored, more ready to face the day. Your mood will be better regulated. Your immune system will be stronger. Your memories will be more consolidated. Your brain will have been cleaned of the waste products that accumulated the previous day. This is the gift of rain sounds. They work with your brain's natural systems to create the conditions for deep, restorative rest. They are not adding anything artificial, not forcing your brain into any unnatural state. They are simply providing the acoustic equivalent of what your ancestors experienced for millions of years. The sound of rain falling in a safe place. The sound that means you can lower your guard. The sound that means the world is taking care of itself and you can rest. The science we have explored tonight reveals the mechanisms behind this effect, but the effect itself is ancient and profound. It connects you to the deepest parts of your brain, the parts you share with your distant ancestors, the parts that remember when survival was more uncertain and rain was a blessing. Those parts of your brain still respond to rain with relief and gratitude and the deep, settling calm that comes from knowing you are safe. So listen to the rain. Let it do its work. Let it activate your parasympathetic nervous system, reduce your stress hormones, quiet your prefrontal cortex, increase your GABA and serotonin, trigger your sleep spindles, and guide you gently into the restorative darkness of sleep. Your brain knows what to do with these sounds. It has known for millions of years. All you need to do is listen and let go and rest. The rain falls. Your breath slows. Your mind quiets. And sleep, that great healer, that nightly miracle, rises up to meet you like a tide, like a wave, like rain soaking into thirsty earth. Rest now. The rain is falling. You are safe. You can sleep. The rain continues its ancient rhythm, and as you rest, your brain moves through landscapes of activity that shift and change like weather itself. Let us continue our journey through the night, exploring more of the remarkable ways your brain and body respond to these healing sounds. In the deepest parts of your sleep, something extraordinary is happening in your neurons. Each neuron in your brain maintains an electrical charge across its membrane, keeping the inside negative relative to the outside. This requires enormous energy. About 50 to 70% of all the energy your brain uses goes simply toward maintaining these electrical gradients through pumps that constantly move sodium out of cells and potassium into them. During deep sleep, as your cortical neurons synchronize and fire less frequently, this energy demand drops, giving your brain a chance to restore its energy reserves. The rain sounds have helped you reach this deep sleep by activating a specific part of your hypothalamus called the ventrolateral preoptic nucleus. This cluster of neurons acts like a sleep switch. When it becomes active, it inhibits the arousal centers in your brain, creating a cascade of sleepiness. The rain's calming effects on your stress systems help activate this sleep switch, allowing it to suppress the wake-promoting systems that would otherwise keep you alert. Your brain's processing of the rain sounds continues even in sleep, but in a transformed way. During REM sleep, when your eyes move rapidly beneath closed lids and dreams unfold in vivid detail, your auditory cortex remains responsive to sounds. However, it processes them differently than during waking. The rain sounds may be incorporated into your dreams. Rain in your dreams may sync with rain in reality, or the emotional quality of rain, its sense of cleansing, renewal, or melancholy, may color the emotional tone of your dream narratives. There is a structure in your brainstem called the pons that plays a crucial role in REM sleep. The pons generates the rapid eye movements and also sends signals to your spinal cord that cause muscle atonia, a temporary paralysis that prevents you from acting out your dreams. The pons is influenced by your overall arousal level. When the rain sounds keep your arousal low throughout the night, your REM sleep becomes more stable, less fragmented, allowing for longer and more complete dream cycles. Your brain is also regulating your body temperature with remarkable precision throughout the night. Your hypothalamus contains a thermostat that maintains your body temperature within a narrow range. During sleep, the set point drops by about half a degree Celsius. This cooling is essential for deep sleep. Rain sounds contribute to this process indirectly. By promoting relaxation and parasympathetic activity, they encourage vasodilation in your extremities, which allows heat to dissipate from your body more effectively. The acoustic properties of rain are themselves fascinating from a physics perspective. Each raindrop is a miniature sphere falling through air, experiencing drag that limits its maximum speed to about 9 meters per second for large drops. When a drop hits a surface, it creates sound through several mechanisms: the impact itself, the splashing that may occur, and the oscillation of the drop if it doesn't break apart. Different surfaces create different frequencies. Leaves produce softer, higher sounds due to their flexibility. Puddles create distinct plop sounds with resonant frequencies determined by the puddle's size. And hard surfaces like pavement create sharper, broader spectrum sounds. This variety in the rain's acoustic signature is part of why it holds your brain's interest without becoming irritating. Your brain's pattern detection systems, which evolved to find signals in noise, are constantly discovering micropatterns in the rain. The slightly denser fall near one area, the change in pitch as wind shifts, the deeper sounds as puddles grow. These patterns are complex enough to be interesting but not so complex as to require active analysis. Your brain's experience of sound is fundamentally different from how a microphone captures it. A microphone converts sound waves into electrical signals in a straightforward way. Your brain performs what's called perceptual completion, filling in gaps and interpreting ambiguous signals based on context and expectation. With rain sounds, your brain is not just passively receiving, it's actively constructing a rich auditory experience, drawing on memories of rain, expectations about how rain should sound, and emotional associations that make rain meaningful. The neurotransmitter dopamine, famous for its role in reward and motivation, also plays a role in your response to rain sounds. Dopamine is not just about pleasure, it's about prediction and learning. Your dopamine neurons fire when something unexpected happens or when you receive a reward. With rain, something interesting occurs. The overall unpredictability of individual drops combined with the predictable texture creates a dopamine response that is engaged but not excited, interested but not demanding. This balanced dopamine state supports relaxation while maintaining a subtle sense of contentment. In your visual cortex, even though your eyes are closed and you're asleep, activity continues. During REM sleep, your visual cortex becomes highly active, generating the visual imagery of dreams. Interestingly, people who are born blind have REM sleep with similar patterns of brain activity, but without visual content in their dreams. The rain sounds, processed by your auditory cortex, may influence what your visual cortex generates. The flowing, rhythmic quality of rain may manifest as dreams of water, movement, or journeys. Your sense of hearing has a property called binaural processing, where your brain compares the signals from both ears to determine where sounds are coming from. Sound reaches the closer ear slightly earlier and slightly louder than the far ear. Your brain can detect time differences as small as 10 microseconds between ears. With rain falling all around, your binaural processing detects sound from all directions simultaneously, creating a sense of being surrounded, enclosed, protected. This 360-degree acoustic environment is part of rain's comforting quality. The evolution of human hearing reflects our history as both predator and prey. Our ancestors needed to detect danger while sleeping, which is why sudden, irregular sounds wake us so easily. But they also needed to be able to sleep despite the constant sounds of nature, wind, water, rain, and the movements of harmless animals. Your brain has inherited this ability to distinguish between sounds that signal danger and sounds that signal safety. The rain, constant and natural, triggers the ancient neural pathways that say, "This is safe, you can sleep." Your heart rate variability, the variation in time intervals between heartbeats, is a powerful indicator of autonomic nervous system balance and overall health. Higher heart rate variability generally indicates better health and greater resilience to stress. During deep sleep, especially when facilitated by calming sounds like rain, your heart rate variability increases. Your heart is not beating like a metronome but with a natural, organic variation that reflects healthy parasympathetic tone. The rain sounds are supporting this healthy variability. In your bones, in your skin, in every cell of your body, circadian clock genes are expressing themselves in rhythmic patterns. These cellular clocks all take their cues from a master clock in your hypothalamus called the suprachiasmatic nucleus, which is primarily synchronized to light and dark. But other factors influence these clocks too, including rest and activity, temperature, and stress levels. By promoting deep, regular sleep, rain sounds help keep your cellular clocks synchronized, which is essential for metabolic health, immune function, and countless other processes. Your lymphatic system, which doesn't have a pump like your heart, relies on muscle movement and breathing to circulate lymph fluid throughout your body. During sleep, when you move less, your breathing becomes the primary driver of lymphatic circulation. The deep, slow breathing encouraged by rain sounds enhances lymphatic flow, helping your body clear waste products and supporting immune function. Each deep breath you take is gently massaging your internal organs and moving lymph through its channels. The rain sounds are affecting your stress axis at multiple levels. The hypothalamic pituitary adrenal axis, or HPA axis, is your body's central stress response system. Your hypothalamus releases corticotropin-releasing hormone, which signals your pituitary gland to release adrenocorticotropic hormone, which in turn signals your adrenal glands to release cortisol. This cascade can be triggered by perceived threats, but it's also regulated by feedback systems. When rain sounds reduce perceived threat and activate calming systems, they help downregulate this entire axis, reducing cortisol production and allowing your body to shift into restoration mode. Your skin, the largest organ of your body, contains millions of nerve endings that are constantly sending information to your brain about temperature, pressure, pain, and pleasure. During sleep, the processing of this sensory information changes. Your somatosensory cortex becomes less active, which is why you're less aware of your body's sensations as you sleep. But this doesn't mean the information stops coming. It's processed at lower levels of your brain, contributing to your unconscious sense of comfort or discomfort. The relaxation induced by rain sounds reduces muscle tension throughout your body, which means fewer pain and pressure signals, allowing deeper sleep. There's a fascinating connection between sound and memory consolidation. Your hippocampus, during sleep, replays the experiences of the day in a compressed, rapid format. This replay is essential for transferring memories from temporary storage in the hippocampus to long-term storage in the cortex. The replay happens in coordination with sleep spindles, those bursts of brain activity we discussed earlier. The stable acoustic environment provided by rain sounds supports longer, more stable periods of deep sleep, which means more opportunity for this crucial memory replay and consolidation. Your brain's white matter, composed of myelinated axons that connect different brain regions, undergoes changes during sleep. Myelin, the fatty substance that insulates axons and speeds up electrical signals, is produced and maintained more actively during sleep. Studies using MRI have shown that sleep deprivation can actually cause slight shrinkage in white matter volume, which reverses with good sleep. By promoting better sleep quality, rain sounds indirectly support the structural integrity of your brain's communication networks. The experience of listening to rain also engages your brain's mirror neuron system, though in a subtle way. Mirror neurons fire both when you perform an action and when you observe someone else performing it. They're believed to be important for empathy and understanding others. When you hear rain, your brain activates memories of times you've seen rain, felt rain, been in rain. The sound evokes a full multisensory memory that includes the sensation of coolness, the smell of wet earth, the sight of drops falling. This rich, embodied response is part of why rain sounds are so evocative and emotionally affecting. Your breathing during sleep goes through fascinating changes. During non-REM sleep, your breathing is regular and controlled primarily by automatic centers in your brainstem that monitor carbon dioxide levels in your blood. During REM sleep, your breathing becomes irregular, influenced by the emotional content of dreams. Throughout the night, your respiratory rate gradually slows. In deep sleep, you might breathe as slowly as 12 to 14 times per minute, compared to 16 to 20 times per minute while awake. This slow breathing maximizes the efficiency of gas exchange in your lungs and reduces the work your heart must do. The phenomenon of auditory scene analysis continues throughout your sleep. Your brain maintains a model of the acoustic environment even when you're not conscious. This is why certain sounds can wake you. They violate the model your sleeping brain has constructed. A sudden silence can wake you as readily as a sudden noise. Rain sounds create a stable model, a predictable acoustic scene that your sleeping brain can monitor with minimal resources, allowing more of your brain to engage in restorative processes rather than vigilance. Your muscles undergo specific patterns of relaxation during different sleep stages. During non-REM sleep, your muscles remain somewhat tense, though more relaxed than during waking. During REM sleep, most of your voluntary muscles become completely paralyzed, with exceptions for your diaphragm, which keeps you breathing, and your eye muscles, which create the rapid eye movements. This muscle atonia is generated by the pons releasing neurotransmitters that hyperpolarize motor neurons in your spinal cord, making them unable to fire. The overall relaxation promoted by rain sounds makes these transitions between sleep stages smoother. Your endocrine system is following its nighttime rhythms. Growth hormone, crucial for tissue repair and growth, is released primarily during deep sleep, with the largest pulse occurring in the first deep sleep cycle of the night. Testosterone production peaks during REM sleep. Prolactin levels rise during sleep, supporting immune function. All these hormonal rhythms depend on good sleep quality. By supporting deeper, less fragmented sleep, rain sounds allow these essential hormonal patterns to unfold properly. The sensation of time passing undergoes profound changes during sleep. During REM sleep, dreams that seem to last hours may occupy only minutes of clock time. During deep sleep, you may lose all sense of time passing. Your brain's ability to track time depends on working memory and attention, both of which are largely offline during sleep. The timelessness of deep sleep is part of its restorative power. You exist outside of time's pressure, in a state where healing and restoration can occur at their own pace. Your eyes, although closed, are moving in characteristic patterns that reflect your sleep stage. During light sleep, they may roll slowly. During REM sleep, they dart rapidly, tracking the imagery of dreams. Even these movements serve a purpose. They help maintain the health of your corneas and the cleanliness of the surface of your eyes. The tears that continuously bathe your eyes during waking are still produced during sleep, and eye movements help distribute them. The deep relaxation that rain sounds promote allows even these small automatic movements to occur with less tension. The concept of sleep pressure we touched on earlier involves more than just adenosine accumulation. Your brain maintains a homeostatic sleep drive. The longer you're awake, the stronger the pressure to sleep becomes. This is separate from your circadian rhythm, which tracks time of day. When these two systems align, when your homeostatic sleep drive is high and your circadian rhythm says it's nighttime, you experience optimal sleep. Rain sounds don't directly affect these systems, but they do remove barriers to sleep, allowing the natural pressure and rhythm to work effectively. Your oral health is even affected by sleep quality. During sleep, your salivary glands produce less saliva, which is why you wake with a dry mouth. This reduced saliva flow means bacteria can multiply more easily, which is part of why dental hygiene before bed is important. Stress can make this worse by further reducing saliva production. By reducing stress, rain sounds indirectly support better oral health during sleep. This might seem like a small thing, but the health of your mouth is connected to heart health, immune function, and overall well-being. The network of blood vessels in your brain, called the cerebral vasculature, changes its activity during sleep. During deep sleep, blood flow to your cortex decreases while blood flow to subcortical structures may increase. This redistribution of blood reflects the changing metabolic needs of different brain regions. The glymphatic system we discussed earlier depends on these vascular changes. As blood vessels subtly contract and expand in slow waves during deep sleep, they create a pumping action that helps drive cerebrospinal fluid through brain tissue, clearing away waste. Your sense of balance, governed by your vestibular system in your inner ears, is closely connected to your auditory system. They share the same cranial nerve. During sleep, especially during REM sleep, your vestibular system can be activated by dreams, creating sensations of movement, falling, or flying. The rain sounds, processed in nearby auditory structures, may influence vestibular activity, though this connection is subtle. The sense of being grounded, stationary, safe while listening to rain may reflect both auditory and vestibular processing working together to create a sense of stable security. Your facial muscles, even in sleep, reflect your emotional state. Positive dreams cause subtle smiles. Anxious dreams cause furrowed brows. These expressions are generated by your limbic system, particularly your amygdala and cingulate cortex, and they feed back to influence your emotional state. Facial expressions don't just reflect emotions, they amplify them. The emotional calm induced by rain sounds leads to more peaceful facial expressions during sleep, which in turn reinforces the sense of peace, creating a beneficial feedback loop. The phenomenon of sleep inertia, that groggy feeling when you first wake up, is related to how deeply you've been sleeping. Waking from deep sleep causes more severe sleep inertia than waking from light sleep. Your cortex needs time to warm up, restoring full activity after the low activity state of deep sleep. Interestingly, while rain sounds help you achieve deeper sleep during the night, they also create a more stable acoustic environment that reduces the likelihood of jarring awakenings, allowing you to surface more gradually and naturally, reducing severe sleep inertia. Your kidneys adjust their activity during sleep, producing more concentrated urine and less volume, which is why you don't need to urinate as frequently during the night as during the day. This is controlled by antidiuretic hormone, which increases during sleep. However, stress and poor sleep can disrupt this rhythm, leading to frequent nighttime urination. By promoting better sleep quality through stress reduction, rain sounds help maintain proper nighttime kidney function and allow for uninterrupted sleep. The chemistry of your synapses, the connections between neurons, changes during sleep. During waking hours, synapses strengthen in response to learning and experience, a process called potentiation. During sleep, especially during deep sleep, a process called synaptic homeostasis occurs. Weaker synapses are pruned away, while important ones are maintained or strengthened. This pruning is essential. If synapses only strengthen and never weaken, your brain would become oversaturated, unable to form new memories or learn new skills. The deep sleep promoted by rain sounds supports this crucial housekeeping. Your brain's pH, the acidity or alkalinity of its tissues, fluctuates with activity level. Active neurons produce carbon dioxide and lactate, which make tissues slightly more acidic. During deep sleep, as neural activity decreases, your brain's pH becomes slightly more alkaline. This pH change affects how proteins fold, how enzymes work, and how ions move across membranes. It's part of the restoration that occurs during sleep. The deeper and more stable your sleep, supported by the calming effects of rain sounds, the more complete this pH normalization can be. The experience of sound is fundamentally relational. It requires both a source and a listener, both vibration and perception. The rain exists independently of you, falling whether you hear it or not. but the experience of rain sounds exists only in the interaction between those vibrations and your auditory system. This might seem like a philosophical distinction, but it points to something profound. Your brain is not passively receiving the world but actively constructing your experience of it. The peace you feel when hearing rain is not just in the rain, it's in your brain's response, shaped by evolution, experience, and the needs of this present moment. Your joints and connective tissues benefit from the stillness of deep sleep. During the day, constant movement and weight-bearing compress cartilage and squeeze fluid out of intervertebral discs. During sleep, especially when lying down, these structures rehydrate and expand, restoring their shock-absorbing properties. The deep, still sleep promoted by rain sounds gives your musculoskeletal system maximal opportunity for this restoration. This is part of why good sleep is so important for recovery from physical activity and for managing conditions like arthritis. The electromagnetic fields generated by your brain's electrical activity extend slightly beyond your skull. These fields are incredibly weak, far too weak to affect other people or devices, but they can be measured with sensitive equipment like EEG machines. During deep sleep, when large populations of neurons fire in synchrony, these fields show characteristic slow waves. The patterns change in REM sleep, becoming faster and more complex. These electrical rhythms are like the brain's music, and rain sounds help conduct this nightly symphony into its most restorative movements. Your gut microbiome, the trillions of bacteria living in your digestive system, follows circadian rhythms and is influenced by your sleep patterns. These microbes produce neurotransmitters, including GABA and serotonin, and they communicate with your brain through the vagus nerve and through hormonal signals. Poor sleep disrupts the microbiome's healthy patterns, while good sleep supports them. By promoting better sleep, rain sounds indirectly support the health of these crucial microbial partners, which in turn supports your mood, immune function, and overall health. The process of breathing during sleep is more complex than simple inhalation and exhalation. Your diaphragm, the primary breathing muscle, must contract and relax thousands of times per night. The intercostal muscles between your ribs assist, especially during REM sleep when breathing becomes more irregular. During deep sleep, breathing shifts more toward diaphragmatic breathing, which is more efficient and promotes better oxygenation. The relaxation induced by rain sounds encourages this optimal breathing pattern even before sleep begins. Your brain's ability to heal from injury, a property called neuroplasticity, is enhanced during sleep. Whether you're recovering from a concussion, a stroke, or just the normal microdamage that occurs from daily living, sleep is when your brain repairs itself most effectively. Growth factors are released, damaged proteins are cleared away, new connections are formed. The quality of this healing depends on sleep quality. Deep, restorative sleep, supported by the calming acoustic environment of rain sounds, provides optimal conditions for neural healing and regeneration. The sensation of sound is not limited to your ears. Sound waves, especially at lower frequencies, can cause subtle vibrations throughout your body. You may have noticed this at a concert where you feel the bass in your chest. Even the gentler sounds of rain create minute vibrations, though you're unlikely to consciously perceive them. These vibrations are detected by mechanoreceptors throughout your body and add to the multisensory experience of listening to rain, creating a full-body sense of being immersed in the sound. Your dreams during REM sleep serve multiple functions: emotional regulation, memory consolidation, problem solving, and creativity. The emotional content of dreams is often more intense than waking emotions, allowing you to process feelings in a safe, simulated environment. The rain sounds, by influencing your emotional state before and during sleep, may influence dream content, potentially making dreams calmer, more pleasant, or more focused on themes of cleansing and renewal. This emotional processing during sleep is essential for mental health. The temperature of your brain is regulated independently from your body temperature, to some extent. Your brain produces enormous heat from its metabolic activity, and this heat must be dissipated. Blood flowing through your brain carries heat away, and the venous blood leaving your brain is warmer than the arterial blood entering it. During sleep, as brain activity decreases, less heat is produced. The slight cooling of your brain during sleep is important for many cellular processes, including DNA repair and protein synthesis. Your hearing remains the most alert of your senses during sleep. While your other senses largely shut down, you don't see, taste, or smell much while sleeping. Your auditory system stays online, monitoring for important sounds. This makes sense evolutionarily. Your ancestors needed to hear predators or danger while sleeping. The rain sounds occupy this monitoring function with safe, non-threatening input, allowing the rest of your brain to fully disengage from vigilance and enter deep restoration. The rhythm of sleep itself, the cycling through stages, follows a pattern called ultradian rhythms, which are shorter than circadian, daily rhythms. A complete sleep cycle lasts about 90 minutes. You'll typically go through 4 to 6 cycles in a night. Early cycles contain more deep sleep, later cycles contain more REM sleep. This architecture is carefully regulated by interactions between multiple brain regions. Disruptions to this architecture, from stress or environmental noise, reduce sleep quality. Rain sounds, by maintaining a stable environment, help preserve the natural sleep architecture. Your experience of self, that sense of being you, depends on activity in specific brain networks, particularly the default mode network we mentioned earlier. During deep sleep, this network's activity changes dramatically. The boundaries of self become less defined. This might sound abstract, but it's part of sleep's restorative power. The energy-intensive work of maintaining a coherent self-identity can pause, allowing other processes to use those resources. When you wake, your sense of self reassembles, refreshed. And so the rain continues through the deep hours of night, and your brain continues its remarkable work. Every system, from the largest networks spanning your entire cortex to the smallest molecular machines inside individual neurons, is engaged in the essential work of restoration. The rain sounds that accompanied you into sleep continue to support this work, maintaining the conditions that allow healing to occur. The night stretches on, dark and peaceful, and the rain falls steadily, and you rest. You are held by rhythms older than language, older than consciousness itself, the rhythm of rain, the rhythm of breath, the rhythm of a heartbeat pacing slowly through the night. These rhythms overlap and resonate, creating a harmony that needs no listener, a peace that exists simply because you are alive, breathing, resting, healing. Soon enough, morning will come. Light will return. Your brain will reverse the processes that led you into sleep, gradually restoring alertness and waking consciousness. But that is still hours away. For now, there is only this: the rain, the breath, the heartbeat, the sleeping brain performing its nightly miracle of restoration. Rest deeply. The rain is still falling. You are still safe. Sleep continues its healing work. The night has reached its deepest point now, that quiet time between midnight and dawn when the world seems to hold its breath. The rain continues, patient and eternal, and your brain moves through the most profound stages of its nightly restoration. Let us continue exploring the intricate dance between sound, sleep, and the miraculous organ that makes you who you are. Your neurons communicate through synapses using molecules called neurotransmitters, but there's another form of communication happening simultaneously. Neurons also release what are called neuromodulators, chemicals that don't directly trigger the next neuron to fire but instead adjust how sensitive it is to other signals. During sleep, the balance of neuromodulators shifts dramatically. Acetylcholine levels drop during deep sleep but rise during REM sleep. Histamine, which promotes wakefulness, decreases. These shifting chemical tides are influenced by your overall arousal state, which the calming rain sounds help keep low and stable. The cells in your brain are not just neurons. In fact, neurons make up only about 50% of brain cells. The other half are glial cells, which were once thought to be merely supportive tissue but are now known to play active roles in brain function. Astrocytes, star-shaped glial cells, help regulate the chemical environment around synapses, provide nutrients to neurons, and are involved in the glymphatic system's waste clearance. During sleep, astrocytes change their shape, shrinking slightly to allow more space for cerebrospinal fluid to flow through brain tissue. This physical transformation is part of how sleep cleanses your brain. Your sense of hearing has a remarkable feature called the cocktail party effect, your ability to focus on one conversation in a noisy room while filtering out others. This selective attention is managed by your auditory cortex and prefrontal regions. During sleep, this selective filtering changes. Your brain continues to monitor sounds but does so with different priorities. Your own name might wake you, as might a baby's cry if you're a parent, but equally loud neutral sounds might not. The rain sounds, being emotionally neutral and non-threatening, are filtered into the background, present but not alerting. The structure of water itself contributes to the unique sound of rain. Water molecules form hydrogen bonds with each other, creating a liquid with unusual properties. These bonds give water its high surface tension, which affects how drops form and fall. They also affect how sound travels through water and how water absorbs sound energy. When a raindrop hits a surface, some of the kinetic energy becomes sound, but most is absorbed as heat or used to deform the drop. The physics of water makes rain sounds possible, and the physics of your ear makes hearing them possible, too. two sets of natural laws working together to create your experience. Your blood-brain barrier, a selective filter that protects your brain from harmful substances in your bloodstream, undergoes changes during sleep. This barrier is formed by specialized endothelial cells lining your brain's blood vessels, held together by tight junctions. During sleep, the permeability of this barrier changes in subtle ways, allowing certain beneficial molecules better access to brain tissue while maintaining protection against toxins. The reduced stress hormones that result from listening to calming rain sounds help maintain the integrity of this crucial barrier. The concept of brain waves we've discussed refers to synchronized electrical activity across populations of neurons. But individual neurons are firing constantly, even during sleep. A single neuron might fire anywhere from once per second to hundreds of times per second, depending on its type and what it's doing. During deep sleep, cortical neurons tend to alternate between periods of firing and periods of silence, altogether, which creates the slow waves seen on EEG. This synchronization is actually less complex than the waking brain's activity, but it serves essential functions for restoration and memory processing. Your olfactory system, responsible for smell, is unique among your senses and having direct connections to your limbic system without first passing through the thalamus. This is why smells can evoke powerful emotional memories. During sleep, your sense of smell remains somewhat active, though diminished. Interestingly, pleasant smells during sleep have been shown to improve the emotional tone of dreams. While rain sounds are auditory, they often evoke olfactory memories, the smell of wet earth, called petrichor, or the fresh smell of ozone after a thunderstorm, enriching the multisensory experience even when no actual smell is present. The mitochondria in your neurons, often called the powerhouses of the cell, are working differently during sleep than during waking. These tiny organelles produce ATP, the energy currency your cells use for everything they do. During waking, neurons demand enormous amounts of ATP for signaling. During sleep, with reduced signaling demands, mitochondria can shift some of their activity toward maintenance and repair. They clear out damaged proteins, repair their own DNA, and restore their membranes. The energy saved by reduced neural activity during sleep is invested in cellular maintenance. Your proprioception, your sense of where your body parts are in space, is largely offline during sleep. This sense is usually maintained by constant feedback from receptors in your muscles, tendons, and joints, processed by your parietal cortex and cerebellum. During sleep, especially during the muscle autonomy of REM sleep, this feedback loop is dampened. This is partly why dreams often involve distorted body awareness or impossible movements. The relaxation induced by rain sounds enhances this natural disconnection from body awareness, deepening the sense of rest. The phenomenon of sleep talking occurs when motor control of speech muscles doesn't fully shut down during sleep. Your brain is generating language, usually during REM sleep, and some of the motor commands leak through to your vocal muscles. This is more common during lighter sleep or when transitioning between sleep stages. The stable, deep sleep promoted by rain sounds may actually reduce sleep talking by helping you maintain consistent sleep stages without frequent transitions. Your genes, the DNA in every cell, are not static instructions but dynamic systems that are constantly being turned on and off. This process, called gene expression, follows circadian rhythms. Hundreds of genes are expressed more during sleep than during waking, and vice versa. These clock genes help regulate everything from metabolism to immune function. During sleep, genes involved in cellular repair and synthesis are upregulated, while genes involved in stress responses are downregulated. Quality sleep, supported by the calming effects of rain sounds, allows these genetic programs to run optimally. The experience of pain is dramatically reduced during sleep. Your pain threshold, the point at which a stimulus becomes painful, increases during deep sleep. This happens because pain signals must be processed by your cortex to be consciously experienced, and during sleep, the cortex is less responsive to ascending sensory signals. This reduced pain sensitivity is part of why sleep is so healing for people with chronic pain conditions. The deeper sleep facilitated by rain sounds provides more relief from pain. Your immune system's activity follows a strong circadian rhythm, with many immune functions peaking during sleep. Natural killer cells, which attack virus-infected cells and cancer cells, become more active. Inflammatory cytokines that help fight infections are released in pulses during sleep. The connections between your nervous system and immune system are extensive. Stress hormones suppress immune function, while the relaxed state induced by rain sounds supports it. This is part of why people who sleep poorly get sick more often. The cerebellum, which we've touched on before, contains about 69 billion neurons, more than the rest of your brain combined. Despite this enormous number, the cerebellum occupies only about 10% of your brain's volume because its neurons are packed extremely densely. During sleep, the cerebellum is involved in consolidating motor memories, the kind of memory that allows you to ride a bike or play an instrument without conscious thought. The practice you put in during the day is installed into motor memory during sleep, particularly during REM sleep. Your experience of consciousness, that sense of awareness that you are aware, may depend on specific patterns of information integration across your brain. Neuroscientist Giulio Tononi's integrated information theory suggests that consciousness arises when information is both highly differentiated and highly integrated. During deep sleep, integration decreases, different brain regions act more independently, and consciousness fades. During REM sleep, integration increases again, and consciousness returns in the altered form we call dreaming. Rain sounds support these natural transitions by maintaining stable conditions. The sound of rain has psychological associations that enhance its physiological effects. For most people in temperate climates, rain is associated with safety, shelter, and staying indoors. These associations are learned from childhood experiences and reinforced throughout life. When your brain recognizes rain sounds, it activates these associated concepts: shelter, safety, permission to rest. This cognitive layer adds to the direct neurological effects, creating a powerful combined influence on your state of arousal and relaxation. Your tear production doesn't stop during sleep. Your lacrimal glands continue producing tears that keep your eyes moist and protected. However, tear production does decrease during sleep compared to waking. The composition of tears also changes throughout the day, with more protective proteins at night. These tears drain through tiny ducts in the corners of your eyes into your nasal passages, which is why your nose runs when you cry. During sleep, this drainage continues, though you're unaware of it. The overall relaxation of your facial muscles during deep sleep, promoted by rain sounds, may improve the function of these drainage pathways. The electrical resistance of your skin, which can be measured as galvanic skin response, changes dramatically between waking and sleeping states. During waking and especially during stress, your sweat glands become more active, which increases your skin's electrical conductivity. During deep sleep, sweat gland activity decreases and skin resistance increases. This is one of many physiological markers that distinguish sleep from waking. The reduction in stress and arousal caused by rain sounds leads to measurable changes in skin conductivity even before sleep begins. Your brain's need for oxygen doesn't stop during sleep, though it does decrease. Your brain uses about 20% of the oxygen your body consumes, despite being only 2% of your body weight. During deep sleep, oxygen consumption drops by about 15 to 20% as neural activity decreases. This reduced demand means your heart can pump a bit more slowly and your breathing can be a bit shallower while still maintaining adequate oxygenation. The efficient, relaxed breathing pattern encouraged by rain sounds supports this optimal nighttime respiration. The phenomenon of exploding head syndrome, a harmless but startling condition where people hear a loud bang as they fall asleep, is thought to be caused by a glitch in the brain's transition from waking to sleeping. Normally, the auditory neurons should decrease their activity gradually, but sometimes they fire all at once before shutting down, creating the perception of a loud noise. This is more common during stressful periods or when sleep is disrupted. The smooth transition to sleep facilitated by rain sounds may reduce the likelihood of such phenomena. Your spinal cord, often thought of as simply a communication pathway between brain and body, actually contains complex neural circuits that can generate their own patterns of activity. During sleep, these spinal circuits are modulated differently than during waking. Motor reflexes, for example, are dampened during REM sleep to prevent movements. Sensory signals from your body are also filtered more heavily before reaching your brain. This spinal-level filtering is part of what allows you to sleep despite ongoing sensory input from your body. The overall reduction in arousal from rain sounds enhances this filtering. The venous blood leaving your brain carries away not just carbon dioxide but also heat and metabolic waste products. This drainage occurs through a complex system of veins and sinuses that eventually empty into the jugular veins in your neck. During sleep, as brain temperature and metabolic rate decrease, the composition of this venous blood changes. Less lactate, less CO2, less heat, all signs of a brain at rest. The glymphatic system works alongside this venous drainage, and together they constitute your brain's waste management system, working best during the deep sleep that rain sounds help promote. Your tongue, during sleep, tends to relax backward toward your throat. In some people, this relaxation can contribute to snoring or sleep apnea. The muscles of your throat and airway also relax during sleep. Your brain must maintain enough tone in these muscles to keep your airway open while also allowing the deep muscle relaxation of sleep. This balance is managed by your brainstem, which monitors oxygen and carbon dioxide levels and adjusts breathing effort accordingly. The overall muscle relaxation promoted by rain sounds is beneficial, but your brainstem always maintains the minimum tension necessary to keep you breathing. The mathematics of neural networks in your brain is staggeringly complex. Each neuron connects to thousands of others, and the pattern of connections is constantly changing through learning and experience. The total number of possible brain states, different patterns of which neurons are active, is effectively infinite. During sleep, your brain explores different states than during waking. Sleep allows your neural networks to reset in some ways, breaking out of the patterns they fell into during the day. This resetting may be part of why sleep is so important for creativity and problem solving. Your body's production of new blood cells continues during sleep. Your bone marrow, particularly in your ribs, spine, and pelvis, contains stem cells that constantly produce red blood cells, white blood cells, and platelets. This production follows a circadian rhythm, with some aspects enhanced during sleep. The growth factors and hormones released during sleep support this hematopoiesis. Your entire blood supply is replaced about every 4 months, and much of this replacement work happens while you sleep. The experience of silence is not the absence of neural activity in your auditory system, but a specific pattern of activity. Your auditory neurons have a baseline firing rate even in complete silence. What you perceive as silence is this baseline activity. Rain sounds, being relatively quiet and steady, don't dramatically increase firing rates but instead change the pattern, creating a textured soundscape that your brain perceives as actively pleasant rather than merely absent of unpleasant sounds. This distinction matters for sleep. Pleasant sounds are more conducive to rest than mere silence. Your dreams during REM sleep are accompanied by measurable changes throughout your body. Your heart rate becomes more variable, your breathing becomes irregular, your blood pressure fluctuates, and your extremities may twitch slightly despite the muscle atonia affecting your major muscle groups. These physiological changes reflect the emotional intensity of dreams. The calmer emotional state induced by rain sounds may lead to less physiologically intense dreams, with fewer spikes in heart rate and blood pressure, contributing to more restorative sleep. The proteins in your brain are constantly being synthesized, modified, and broken down. This protein turnover is essential for brain function. During waking, the balance tips toward protein breakdown as proteins are damaged by the brain's intense metabolic activity. During sleep, synthesis increases and breakdown decreases, allowing your neurons to repair and replace damaged proteins. This protein homeostasis is fundamental to brain health. Chronic sleep deprivation leads to accumulation of damaged proteins, which may contribute to neurodegenerative diseases. Quality sleep, supported by rain sounds, protects against this. Your brain's interpretation of sound is not just about detecting frequencies and volumes, but about extracting meaning. Even in sleep, your brain is constantly asking, "What made that sound? Is it important? Does it require action?" With familiar, meaningful sounds like your name or a smoke alarm, your brain may rouse you to consciousness. With meaningless or irrelevant sounds, your brain incorporates them into sleep without awakening you. Rain sounds are recognized as natural, non-threatening, and requiring no action, allowing your brain to maintain sleep while still processing the auditory input. The cerebrospinal fluid that bathes your brain and spinal cord is not static but constantly flowing. It is produced by specialized structures called choroid plexuses in your brain's ventricles at a rate of about 500 milliliters per day, meaning your entire CSF volume is replaced several times daily. During sleep, the flow patterns of CSF change, and its movement through brain tissue increases as part of the glymphatic system. This flowing CSF carries away waste products, supplies nutrients, and helps regulate the brain's chemical environment. The deep sleep facilitated by rain sounds optimizes this crucial flow. Your brain's reward system, centered around the nucleus accumbens and ventral tegmental area, is involved in motivation and pleasure. This system is less active during deep sleep but becomes more active during REM sleep, contributing to the sometimes intensely emotional nature of dreams. During waking, this system can become dysregulated by stress, leading to anhedonia, the inability to feel pleasure. The stress reduction from rain sounds helps maintain healthy reward system function, which supports mood and motivation when you wake. The phenomenon of microsleeps, brief episodes of sleep lasting just seconds, can occur when someone is severely sleep deprived, even during activities like driving. During a microsleep, part of your brain enters a sleep state while other parts remain awake. This can be extremely dangerous. Quality nighttime sleep, achieved through good sleep hygiene and supportive conditions like rain sounds, prevents the sleep deprivation that causes microsleeps, keeping you safer during the following day. Your pupils constrict during sleep, especially during REM sleep, and this constriction is controlled by the same brainstem regions that regulate sleep itself. During deep non-REM sleep, your pupils are smaller and relatively stable. During REM sleep, they may move slightly along with your eye movements. This pupillary response is so closely linked to sleep states that it can be used as an indicator of sleep depth. The progression into deeper sleep stages, supported by rain sounds, is reflected in these tiny changes in pupil size behind your closed eyelids. The experience of taste is diminished during sleep. Your taste buds, which are actually clusters of 50 to 100 specialized cells on your tongue, continue to function, but the signals they send are less likely to reach conscious awareness during sleep. This makes sense evolutionarily. You're not eating while sleeping, so taste information isn't immediately relevant. However, strong tastes could still wake you if they signal danger, such as the taste of smoke. The reduced sensory processing during sleep, facilitated by rain sounds, allows resources to be directed toward restoration rather than monitoring. Your bones, seemingly solid and unchanging, are actually dynamic tissues that are constantly being broken down and rebuilt. Cells called osteoclasts break down old bone tissue, while cells called osteoblasts build new bone. This remodeling is influenced by mechanical stress, hormones, and sleep. Growth hormone and testosterone, both released during sleep, promote bone building. The deep sleep that rain sounds support provides optimal conditions for skeletal maintenance and repair, important not just in youth but throughout life as you age. The electromagnetic spectrum extends far beyond what your eyes can see, from radio waves through visible light to gamma rays. Sound waves are not part of this spectrum, they're mechanical vibrations rather than electromagnetic radiation. Yet sound and light are processed by your brain in some similar ways, with specialized regions of cortex dedicated to each and similar principles of pattern detection and scene construction. During sleep, both your visual and auditory processing change, creating the unique perceptual state of dreaming where sounds and sights blend in ways impossible during waking. Your brain's frontal lobes, which reach full maturity in your mid-20s, are among the last brain regions to develop and among the first to show age-related decline. These regions are responsible for executive functions, planning, decision-making, impulse control, and working memory. They're also among the most affected by sleep deprivation. Even one night of poor sleep can impair frontal lobe function, making you more impulsive and less able to think through complex problems. The restorative sleep promoted by rain sounds protects frontal lobe function, keeping your higher cognitive abilities sharp. The sensation of touch is distributed across your entire body through different types of receptors: Meissner's corpuscles for light touch, Pacinian corpuscles for vibration, Ruffini endings for stretch, and Merkel discs for fine details. During sleep, the processing of these signals changes. Your somatosensory cortex becomes less active, raising your touch threshold. It takes a stronger stimulus to wake you. However, touch signals continue to be processed at lower brain levels, contributing to your unconscious sense of comfort or discomfort. The reduced muscle tension from rain sounds reduces the touch signals from pressure points, allowing deeper sleep. Your liver, the largest internal organ in your body, follows strong circadian rhythms in its function. During sleep, your liver focuses more on detoxification and less on glucose production than during waking. It processes the toxins you were exposed to during the day, breaks down drugs and alcohol, and produces bile for fat digestion. Many liver enzymes follow circadian patterns in their activity. The hormonal environment of good sleep, supported by the stress reduction from rain sounds, optimizes liver function, contributing to overall metabolic health. The concept of sleep debt refers to the cumulative effect of not getting enough sleep. If you need 8 hours but only get 6, you accumulate 2 hours of sleep debt. This debt can't be fully repaid by sleeping in on weekends. Your body needs consistent, adequate sleep every night. Sleep debt impairs cognitive function, mood, immune response, and metabolic health. Rain sounds can help you avoid accumulating sleep debt by improving sleep quality and helping you sleep through the night without disruptions. Your brain's evolution over millions of years has resulted in a structure that's been described as triune, 3 brains in 1. The most ancient is the brainstem and cerebellum, governing basic functions. The middle layer is the limbic system, governing emotions and memory. The newest is the neocortex, governing higher thought. During sleep, these layers interact differently than during waking. The newer layers become less active while the ancient layers continue their essential work. Rain sounds, processed by both ancient and modern auditory structures, create a bridge between these evolutionary layers. The quality of your sleep affects your emotional regulation the following day through multiple mechanisms. Sleep deprivation increases amygdala reactivity, your fear and emotion center becomes more sensitive. It also weakens the prefrontal cortex's ability to regulate the amygdala, leading to more emotional volatility. Sleep deprivation increases negative mood and decreases positive mood more than it affects neutral mood. By promoting better sleep through stress reduction and environmental optimization, rain sounds help you wake up more emotionally balanced and resilient. Your body's internal clock, the suprachiasmatic nucleus we mentioned earlier, doesn't just respond to light but also to other time cues called Zeitgebers, German for time givers. These include meal timing, exercise, social interaction, and sleep-wake patterns themselves. Consistent sleep timing reinforces your circadian rhythms, while irregular sleep timing disrupts them. Rain sounds can be part of a consistent bedtime routine, serving as a Zeitgeber that signals to your body it's time for sleep, strengthening your natural rhythms. The phenomenon of lucid dreaming, becoming aware that you're dreaming while still asleep, occurs most commonly during REM sleep. In lucid dreams, parts of your prefrontal cortex that are normally inactive during dreams regain some activity, allowing you to become consciously aware within the dream. Some people can even learn to control their lucid dreams. The stable REM sleep promoted by rain sounds provides a good foundation for lucid dreaming, if that's something you're interested in developing. The dreams themselves may incorporate the sound of rain, weaving it into the dream narrative. Your vocal cords, which vibrate to produce sound when you speak or sing, rest during sleep except during sleep talking. These delicate folds of tissue in your larynx need this rest to recover from the day's use. Professional singers and speakers know that good sleep is essential for vocal health. The relaxation of throat muscles during deep sleep, supported by the calming effects of rain sounds, allows your vocal cords to rest completely, maintaining their flexibility and function for the next day. The mathematical pattern we mentioned earlier, that rain sounds contain 1/f or pink noise, appears throughout nature and has deep connections to chaos theory and complexity science. This pattern exists at the border between order and randomness, between predictability and surprise. Your brain, which evolved in an environment full of such patterns, seems to find them inherently pleasing and non-taxing to process. This may be part of why natural sounds like rain, rustling leaves, and ocean waves are more relaxing than artificial sounds like white noise or music. Your DNA, the genetic blueprint in every cell, is constantly being damaged and repaired. Ultraviolet light, oxidative stress, and normal metabolic processes cause thousands of DNA lesions per cell per day. Fortunately, your cells have sophisticated DNA repair mechanisms that fix most of this damage. These repair processes work best during sleep, when cells are under less metabolic stress. By promoting deep, restorative sleep, rain sounds indirectly support the genetic integrity of all your cells, including the neurons in your brain. The experience of time and dreams is fascinating and strange. Dream time can be compressed or expanded relative to clock time. You might dream an entire lifetime in minutes, or dream events in real time. The brain regions that track time during waking, particularly in your prefrontal cortex and basal ganglia, function differently during dreaming. Without the constraints of real-world physics, dream time becomes fluid. The timelessness of deep sleep, where dreams may not occur or may not be remembered, is perhaps the most complete form of rest, existing outside of time's flow entirely. And so the deepest hours of night continue their passage. The rain falls without hurry, without purpose, simply because atmospheric conditions have made it so. Your brain rests without effort, without intention, simply because evolution has made it so. The intersection of these two natural processes, rain and sleep, creates conditions for the profound restoration that allows you to wake renewed, to face another day of being conscious, of being yourself, of being alive. The night holds you gently. The rain continues its ancient song. Your brain performs its nightly miracles. And you, the conscious being who will wake when morning comes, rest in the deepest peace that nature offers, the peace of sleep, supported by the sound of falling rain. Rest continues. The healing goes on. The night protects you. And the rain falls still,